Hi, I'm Dr. Nadia. How are you feeling today?
I don't understand. I've been sleeping more than usual. I'm exhausted. I'm thirsty all the time. I drink water constantly, but it doesn't help. And I'm eating, but I keep losing weight.
Those symptoms are important. That's why we ran some blood work. Your blood glucose level was 320 milligrams per deciliter. A normal fasting level should be around 70 to 100.
Damn, that's really high.
Yes, and based on your lab results, you do have type 1 diabetes.
Diabetes? I thought that was for older people.
While type 2 diabetes is more common in adults, type 1 is different. It is an autoimmune condition. Your immune system mistakenly attacked the beta cells in your pancreas, the cells that produce insulin.
Insulin? What exactly does that do?
Insulin is a peptide hormone made of 51 amino acids. It is produced by beta cells in a region of the pancreas called the islets of Langerhans. Structurally, insulin has two chains, an A chain with 21 amino acids and a B chain with 30 amino acids connected by disulfide bonds. This precise structure is essential for its function. Even a small structural change can reduce its effectiveness. When you eat carbohydrates like pasta, bread, or fruit, they are broken down into glucose. That glucose enters your bloodstream. As blood glucose rises, insulin is released. Insulin acts like a molecular key. It binds to insulin receptors on muscle, liver, and adipose tissue. This activates a signaling cascade inside the cell, specifically through a pathway involving insulin receptor substrates and protein kinases. The result, glucose transporter proteins, particularly GLUT4 in muscle and fat cells, move to the cell membrane. These transporters allow glucose to enter the cell. Without insulin, the door stays closed and glucose builds up in the bloodstream instead of being used for energy.
After a meal, blood glucose rises. In a person without diabetes, insulin release keeps glucose levels tightly regulated, usually between 70 and 140 milligrams per deciliter. In muscle cells, insulin increases glucose uptake so the cell can produce ATP through glycolysis and cellular respiration. In the liver, insulin stimulates glycogenesis, the conversion of glucose into glycogen for storage. It also inhibits gluconeogenesis, preventing the liver from making even more glucose. In fat tissue, insulin promotes lipogenesis, also known as fat storage, and prevents lipolysis or fat breakdown. Insulin also supports protein synthesis and cellular growth. It is not just a sugar hormone, it is a master regulator of metabolism. But in type 1 diabetes, there is no insulin. Cells begin to starve despite high blood glucose levels. The body turns to fat breakdown for energy, producing ketone bodies. If ketones accumulate, this can lead to diabetic ketoacidosis, a life-threatening condition. This is why untreated type 1 diabetes was once almost fatal.
Before 1921, children diagnosed with type 1 diabetes were placed on starvation diets, sometimes as low as 400 calories per day. It delayed death, but it did not prevent it. Then came Frederick Banting and Charles Best. Working in a small laboratory in Toronto, they isolated insulin from the pancreases of dogs. In 1922, a 14-year-old boy named Leonard Thompson became the first person to receive insulin treatment. He was near death. Within 24 hours of receiving purified insulin, his blood glucose levels dropped. His condition improved dramatically. It was described as a medical miracle. In 1923, Banting and his colleagues received the Nobel Prize. And the patent for insulin? It was sold for $1 because they believed insulin belonged to humanity.
So I'll need insulin for the rest of my life?
Yes, but today we have multiple options. Rapid-acting insulin works within 15 minutes. Long-acting insulin provides steady control for up to 24 hours. You can use either injections, insulin pens, or even an insulin pump that continuously delivers small doses.
Will I still be able to live a normal life? Like go to school, work, exercise?
Yeah, with monitoring and proper insulin use, people with type 1 diabetes live full, healthy lives.
That's strange. That's something I can't even see is the reason I feel so sick.
And it's something equally small that will keep you alive.
Today, insulin is produced using recombinant DNA technology. The human insulin gene is inserted into bacteria or yeast, which then produce insulin that is structurally identical to the natural human hormone. This innovation eliminated the need to extract insulin from animal pancreases and enabled large-scale production of highly purified, consistent formulations. Despite this scientific achievement, insulin has also become central to ongoing debates about drug pricing and access to healthcare. Millions of people worldwide rely on insulin every day, yet in some regions, its cost significantly exceeds production expenses. A therapy that once cost $1 per vial in the 1920s is now frequently discussed in the context of pharmaceutical policy and affordability. Insulin illustrates both the power of molecular biology and the challenges of translating scientific advances into equitable healthcare. It is a small protein of 51 amino acids, but its impact on medicine and society has been profound.
Wow, so this tiny molecule
is one of the most important discoveries in medical history.